11:20 to 12.
Like 40 minutes?
Yes. While Constantine's just setting up right now, I also have some questions earlier on about the AIA learning units. Just to let you know that we're available to give you 3.5 AIA learning units. So in order to get it, just send us an email at marketing@microsolresources.com. Actually, I should have introduced myself earlier on. I'm Annalisa from Microsol Resources, the Director of Marketing. Again, if you want your 3.5 LU, just send us with a request saying looking for AIA LU for V-Ray Day in New York. And if you want your AIA number to be credited, just let us know what that number is. We'll be able to do that. Or we can also give you a PDF with a certificate of completion instead. Okay, guys? Thanks.
Mouse doesn't work for some reason.
Actually, while we're setting up right now, we thought we'd maybe take some Q&A. If you have any questions for Chaos Group right now, we have Brian Russell or Corey Rubadu right now available.
The computer. No, it should be.
It's a quiet group.
I didn't even see this blip. Can we look at your...
Where was that? It's set right. I'm not sure. The cable doesn't want to.
HDMI is giving me some issues.
Okay, so it flushed.
Oh, did we get it that time?
Need a patch.
I don't think it's the cable.
It's probably not. It may be our input.
So it's not seeing anything. We are good.
Great.
Okay, guys, are you ready to start? So the break will be after this demo. Okay, so it's me again, but this time I will be talking about V-Ray for 3ds Max. And yeah, that's one of the most interesting talks today because I have a lot of new stuff to show you in 3ds Max. And it's important to look at the software when you look at Chaos Group's products because everything is first developed for 3ds Max. Like looking at 3ds Max is like looking at the V-Ray core and all the new features are first available here, and after that they move into the different platforms. So even if you do your visualizations in Revit, SketchUp, or Rhino, you can basically look in the future and see what kind of things we have in store for you. Another reason why you should care about 3ds Max is, of course, that at the end of the day, if you want to create really high-end visualizations, that's the tool that you'll probably use for the job, because it has the full palette of tools that Chaos Group provides. Okay, and I will actually do a quick I will look at all the service packs that we have released so far for 3ds Max, because I want to talk a little bit about the evolution of our product. And as I already told you, we base all our updates on our users' demands and needs, and we always have a really huge list of features that we need to implement in our products. But at the same time, we don't want to be too late with our releases. If we have a tool developed, we want to give the users the chance to use it as quickly as possible. And that's the reason why we usually have big updates like V-Ray 2, V-Ray 3, V-Ray 4 in the future that give you a bunch of new tools packed together, and they make a big difference. But in between, we usually release a lot of service packs, and those service packs are the tools that we have been working on in the meantime. So we don't want to delay people waiting for 1 or 2 years to get the new things. We want to get out everything as soon as possible. And the cool thing about doing it is that if you make your tools available, you will get immediate feedback from the community, and you can then modify them and improve them further rather quickly. And with V-Ray 3 for 3ds Max, that's exactly what happened. We released the big update and in V-Ray 3, and afterwards we started releasing service packs, modifying the features and adding new updates. So to take a look at the evolution of V-Ray in Max, I'll start with Service Pack 1. And the features listed here are actually brand new things we have added to the software. So I haven't listed any bug fixes or small changes. Those are all big changes that will affect your everyday work. And in Service Pack 1 we added that. In Service Pack 2 we added a bunch of other new things. The same goes for Service Pack 3. Service Pack 4 has a shorter list, but it actually has one big entry, which is the V-Ray denoiser up at the top, and a couple of other things. And now let's take a look at some of the highlights throughout those service packs. I will not do a lot of live demos of the older features because I want to have enough time at the end to talk about the new things in Service Pack 5 and for our future releases. But some of the things that have changed is, first let's start with material creation and texture handling. So a brand new material was introduced, which is called the scatter volume material. This is a great tool because previously if people had to create materials like this one over here, or if they had to fill a volume with a volumetric shader, they had to use the V-Ray environment fog. Now they no longer have to do it. They can just apply the V-Ray volume material in their shading network, plug it in a V-Ray blend material, for example, add a coating on top and create interesting effects like this one. Of course, the material is rather expensive to render, so you have to be careful when you use it, but in specific cases you just cannot get away without doing it. Another brand new material which was introduced was the stochastic flakes material. To be honest, it was specifically built for the automotive industry. It gives you the ability to create really nice looking flakes with color variations and so on. Another benefit of using this material is that the flakes will look great in a distance, something that used to be a problem with V-Ray flakes in the past. Also, they'll behave really nicely in animations. So I was trying to figure out an architectural application of the flakes, so I was browsing online for images, and I found the image on the left. So I tried to really quickly mimic the same setup using the stochastic flakes material, and I think it looks quite okay. Another changes when it comes to shading and material creation were a couple of changes to the V-Ray material itself. The first one was an introduction of a new BRDF model. So previously, people had access to the phone cohort and Blin BRDF models in the V-Ray material, and they were fine, but some were better in one case, and others were better in a different case. In V-Ray 3.1, we basically added a new BRDF type called the GGX. The model itself is actually called microfacet GGR, but set with the default settings, it gives you the GGX shader. And if I go back and forth with the two slides, you will see the differences between the existing BRDFs and the new one. So currently it's set by default for the V-Ray material, and it works best in almost all cases. Another really cool optimization has to do with opacity mapping. So oftentimes when you create trees, especially with some of the plugins out there, or if you use models, existing models which are from model packs, from model sets, they use opacity textures for the tree leaves, which is something really slow to render. So the ray tracers are always struggling with handling many opacities one behind the other. And that's why in V-Ray 3.1 we have added a new opacity mode to the V-Ray material, actually two of them, two opacity modes. One of them is called stochastic, this one in the middle, and clip, which is the one on the right. So the stochastic one will give you like 99% of what you'll get with the normal evaluation, and the clip will give you some minor differences which don't really matter if you're looking at a tree in a distance or if you're looking at the whole forest. So that's why I strongly recommend that you use the clip one if you can get away with it, because the render time differences are quite significant. So the V-Ray multi-sub texture that you already saw in SketchUp was again a service pack update. And this one gives you the ability to distribute different colors or different bitmaps in between different geometries. It has the ability to do that if you set the IDs of the objects manually, or you can also use one of the random modes in order to do it easily. So the ray traced rounded corners effect was another service pack update. This one is really great because previously with V-Ray you could use the edges texture, as I showed you, to create rounded corners effect during render time. But unfortunately, in some specific cases, the rounded edges were not working properly. So sometimes the concave edges were not being rounded properly, and also if you have multiple objects and you want to intersect them and have a rounded corner in between them, this was impossible. Now with the new ray traced algorithm, this is quite an easy task to achieve. And in this particular image example, those chocolate pieces and the base are basically two separate geometries which are being combined using the rounded edges effect. For the two-sided material, we had a really great update. So people were complaining that, well, the two-sided material is great. It works perfect for creating cloth or fabrics, and paper as well. But the problem was that when you blend between the backside material and the frontside material, you were losing details of one or the other. So basically, if you have a paper, you cannot have the back ink affect the front lighting of the material or the other way around. That's why in V-Ray 3.1 we have added a small checkbox to the two-sided material, which is called multiply by front diffuse, and it will do exactly that. So it will grab the backside texture and the frontside texture, it will multiply them, and you'll see a much more natural looking effect. So then, when it comes to geometry management, there have been a bunch of updates. The first one, and one of the most important ones, was the introduction of the V-Ray instancer. So when you try to scatter multiple geometries or V-Ray proxies around in the set, you can use like additional tools or plugins for 3ds Max in order to do it. But it would be great if you have something really simple built in V-Ray that gives you the ability to do it, and that's the V-Ray instancer. So this one will grab a 3ds Max particle system created with particle flow and will distribute V-Ray proxies or any other object across a surface. And in that particular case, I have used the instancer to scatter the trees around. The best part about it is it works great with the V-Ray multi-subtexture. As an example, the multi-subtexture has a random by particle ID option, and this one gave me the ability to randomize the colors of the different trees. And if you use multiple multi-subtextures in a shading network, you can have random tree colors and random leaf colors at the same time all together. So when it comes to the proxy creation itself, first of all, I have to mention that the V-Ray proxies performance have been improved multiple times in those updates. So now they're rendered in a much more optimized way, and they're basically rendered faster. But having a nice preview, viewport preview for your proxies is also quite important. So people used to apply the following workflow. They'll have a high poly mesh, they'll convert it to a proxy, and they'll have a low poly representation of that mesh built separately, and they'll use that as a viewport preview just to get an idea of where the object is located in the set. But in V-Ray 3.2, we have added a new algorithm which will automatically create the low poly version of your model. And the quality at which it creates it is quite nice. So this is the image you can see in the middle. So this was quite an important update, and you have a bunch of options to control how this low poly version of the mesh is generated. So this is a feature which we still don't have in SketchUp and Rhino, but in the next version we will be implementing it, so you'll be able to enjoy it there as well. So when it comes to V-Ray fur rendering, again, it can be extremely useful in architectural visualizations for creating grass or rugs, for example, or carpet. The V-Ray fur has been optimized a lot. So here you can see the same exact set rendered with V-Ray 3 and then with V-Ray 3.2. And the difference is like twice as fast for rendering. And this is actually thanks to the Embry support that we added for V-Ray fur and for hair rendering in general. And this is a really great example to show you how we really base our development on our users' requests. So I was here in New York 2 years ago, and I was demoing V-Ray 3. There we showed the V-Ray Clipper, which was just a plane at this point. And the first question I got is, why don't you do the Clipper use custom meshes? And this is something we're working on hard, and in Service Pack 3 we were able to get it in the software. And it's really cool to use, it's rendered really fast. So if you have never tried it, you should certainly do so. So now we get to lighting and global illumination. So the Hosek sky model and aerial perspective made their way in 3ds Max first. You saw their application in SketchUp. And another really important thing when it comes to lighting is the light cache. So every time you're rendering interiors, the light cache is the tool that you have to go to. Like, it always has to be set as a secondary GI engine. It's able to calculate close to infinite amount of light bounces in no time whatsoever. And with one of the service packs, we made it even faster because now it can be distributed on your render farm. This option works so well that now it's enabled. You don't have any way to disable it, and it works great out of the box. Environment fog was supported in V-Ray RT, another big request by our users. This was extremely important because rendering volumetrics is something slow usually, something really, really slow. And rendering that interactively gives you the ability to do many iterations rather quickly. Even though the environment fog looks really noisy in RT in the beginning, you can still get a feel of the fog height, fog distance, and the fog color, and also how the light will be scattered inside the volume. The V-Ray frame buffer is a really important part when you work on your scenes. Of course, it already had a pretty big tool set for doing color corrections, lens effects, and so on, but we decided to improve on that even further. The first thing which was added was the support for background images. That is extremely important because usually if you will move your rendered image to a compositing package and do compositing afterwards, you usually render upon a black background. That's a common workflow in the VFX industry, for example. And then in post, you will add the background over there. In order to preview your images, even while rendering in V-Ray in 3ds Max, now you can load the image as a background and get the result on the right. The V-Ray scene settings or the render settings or even your quality settings can now be saved in the V-Ray frame buffer history. So once I click Save Image, V-Ray will write all the render settings in the image itself. And right after that, if you want to load previous settings that you basically forgot, but you know that you did render that image using the settings, you can just right-click on a history entry in the frame buffer and click Load Color Correction or Load V-Ray Settings. Okay, and here you will be able to see that in practice. So I have this scene, and I'm loading different settings from the frame buffer, and I can easily go back to the previous stages that I went through before. Even things like distributed rendering and camera options are saved in there. As I already mentioned in my previous talk, you can save the color corrections from the VFB. That was a service pack update as well. And you can now save them as cube files, load them in Photoshop, load them in Nuke, and apply the same thing that you see in the VFB and start working from there in the post-production stage. And another really cool thing that I lately use quite a bit, if you are used to having projects, 3ds Max projects set, you can make your VFB history relative to the 3ds Max project, and for each project you can have a different history images saved. Of course, virtual reality was getting big after V-Ray 3 was released, so we had to account for that. Again, as a service pack release, first we started supporting the 3ds Max physical camera. That was the first camera change that we did. The great thing about using the 3ds Max 2016 and on physical camera is that it has the automatic exposure control, similar to what I showed you in SketchUp. And then we had to add two different camera types. The first one was the stereo spherical panorama camera, and the second one is the Cube 6x1 camera. Both of them are great for rendering VR images, and both of them can be rendered either with just to preview the VR set or in stereo to be viewed on special VR glasses. And as a tip, when you want to select one or the other camera type, I should say that the cubic camera most of the time works better since it gives you really high resolution near the horizon, near your eye level, whereas the spherical camera has much smaller resolution when it comes to the eye level areas of the image. So in V-Ray 3.3, we did introduce a new image sampler in V-Ray. And this new image sampler improves the workflow in two main ways. The first one is people were complaining that they do render their images with let's say, medium quality, and they get really clean, bright parts of the rendered image, but really noisy, dark parts. And this is not working great in some scenarios. The new image sampler, the variance-based image sampler that we have added, will make sure that you have consistent noise levels throughout the image. On the other hand, it also did open the doors for us for writing our denoising algorithm that you will see in a second. Because you have to have consistent noise levels throughout the whole image in order to do high quality denoising afterwards. Another really cool thing about the new image sampler is that it gives you much more predictable results when you change the threshold of the image sampler. So the threshold is basically the sensitivity of the V-Ray engine. So using the threshold, it finds details in your set and it samples them more. With the new variance-based image sampler, when you decrease the threshold, the image quality increases in a really expected and predictable way. Just as a side note or a tip, people have been complaining that they load V-Ray 3 scene in V-Ray 3.3 with the new image sampler, and it's rendered slower. The reason for that is you have to use different thresholds when you switch to the new image sampler, so that's something you have to account for manually. So then, once we had the image sampler, we added the V-Ray denoiser, which can bring you from here to here for no added render time whatsoever. And this was just a video of different things rendered with the denoiser. So something that I didn't mention in my SketchUp talk is that the denoiser will work well with buckets, but it will also work really cool with the progressive sampler. So if you run progressive rendering and you have the denoiser render element, V-Ray will denoise the image in increments. So you can be looking at the denoiser channel, and once you like the denoiser result, you can interrupt the progressive rendering engine and save the image on your hard drive. So that's really cool. And another thing that you saw on during this video was that it will work for animations as well. So it will not produce any artifacts like flickering and so on, because it will know that it's an animation and it will look at a couple of frames at the same time and will do a really intelligent denoise of the whole sequence. And a really big thing that we are still working on is the GPU engine. This started like a really small project in the company, something that we were experimenting with a couple of years ago. But then the interest in GPU rendering increased in general in between 3 people around the world. So now we have a really big dedicated team that exclusively does GPU feature support. And our main goal is to have something rendered on the CPU and on the GPU exactly the same way, without you having to change materials, without having to change lights or your general workflow. And in that regard, with each service pack, we have introduced a lot of new things which work nicely on the GPU, which were previously not supported, like GPU subsurface scattering and light cache can now be used. A lot of the procedural textures in 3ds Max, which are crucial for serious production, are now supported, fully supported. And fur and different hair primitives or geometries can now be rendered easily and in a really quick fashion. Okay, and that's not all. If I give you the full list of new features that we do support on the GPU, it will just take a while for me to explain everything. But nowadays, it's safe to say that you can just open a CPU setup, render it on the GPU, and you'll most probably get exactly the same result. Towards the end of this talk, I will tell you about something new that we're working on, which will help greatly in that regard. Okay, and now we get to the new service pack. This is the latest thing that we have released for 3ds Max. This is Service Pack 5, and I will take a look at the features in more depth. So this is a short list of the features. And the first and really cool one is called adaptive lighting. So in V-Ray 3, we have introduced something called probabilistic lighting. So let me jump into 3ds Max and show you that real quick. So if I go to the global switches of V-Ray, we had an option called probabilistic lighting. And once you enable the option, V-Ray will do the following. And there's also a value, which says 8, for example. Once you enable it, when V-Ray starts rendering, it will shoot a ray from the camera, and it will try to render this point, for example, in space. And instead of sampling all the lights in the set, it will just sample 8 random lights from your set, making the render process much, much faster. But unfortunately, it was producing artifacts in specific cases, and the reason for the artifacts was the randomness or the random algorithm with which V-Ray was choosing the light sources. Now with V-Ray 3.5, we have a much better algorithm. This one is called adaptive lights, and this will be smart about it. It will try to find the most important lights or the lights which are closer to the point of interest, and it will only shoot rays towards those light sources. So here's a video example. We have a bunch of lights in this scene, which was provided to us by clients. And those are just the V-Ray lights. He has a lot of 3ds Max lights as well. And on the left, you will see an image rendered with full light evaluation, so the standard way of rendering it. On the right, we have used adaptive lighting with 16 light sources, I think. So there's no visual difference between the two images, and one of them was rendered for 11 minutes and 12 seconds, and the other one for just 3 minutes and 53 seconds. And the algorithm works so well that we basically enabled it by default, and there's no real reason why you shouldn't use it in all your projects. And I know that most of you are dealing with really huge sets with big buildings, a lot of light sources. You will benefit greatly from that. Keep in mind that this feature is in Revit, V-Ray for Revit already. It will be released with the next service pack release, and it will make it into SketchUp and Rhino soon. So then an entirely new rendering mode was introduced in V-Ray, and now I'll switch to 3ds Max and show you that in practice. Okay, so here's my set, and I can always start rendering using the standard shortcut in the Max toolbar, and this is the effect I'll get. If I want to switch to V-Ray RT or to the interactive rendering mode right now, I'll have to go to the settings of 3ds Max, switch to active shade, and start active shade rendering. And active shade uses separate options, so you have to take care of those and balance both together. It has a different resolution and so on. So sometimes it's not that handy to enable or to start doing interactive renderings. That's why in V-Ray 3.5 we have added this small button over here, which I'll try to zoom into over here. And this will start interactive production rendering without you having to deal with the 3ds Max menus. So if I click on that, you will see that my image is rendered rather quickly. And then I can start moving the camera and interact with my set any way I want. The image will update automatically. What I want to point out is when I do so, the light cache is being calculated first, and then the actual production rendering process starts. So the thing that you see here is not V-Ray RT. That's the production engine rendering my image. So let's improve this image a little bit, and to give you a feel of what it's like to use that new engine. So I'll open the material editor, but the other one. And I will apply a two-sided material to this geometry, because I have a light source in the back. And then let me expand the V-Ray light lister and change some light intensities. So you can see the two-sided material effect clearly, rendered interactively. So then let me do something else. I'll apply backside material, a red one. And this will change the image, and it fades in a really nice way. And then I can plug a texture as a backside material color to make something more interesting, like so. And I did that whole thing using the new engine. You can see how quickly I can get final results. And since this is the V-Ray production rendering mode, I can just wait for the image, save it, and use it. Another feature of the IPR is you can disable the force progressive sampling option, this one over here, and actually render with buckets. Oops, but I have to start it from the frame buffer. And now, every time I move my camera, V-Ray will restart the process and it will start rendering with buckets, which is also something really cool. Okay. V-Ray RT, the interactive rendering solution, has also been updated quite a bit. A couple of really handy options have been added in the frame buffer itself. So let me load another scene example.